For this statistics video, we are going to continue our talk about percentiles, and we're going to be finding percentiles from a table. We're also going to be looking at finding percentiles from a set of data, either by looking for the specific percentile or taking one of the data points and trying to figure out what percentile that data point is in. Alright, so here's what we got. We have a survey done by, I'd say, 50 people. I'm just telling you that offhand because I've counted up all of the kids in this survey, and there are 50 people in this survey who reported how much sleep they get per night on a school day. And if you're going to read this chart, the chart is basically read like this. There are 2 students who get 4 hours of sleep, 5 students who get 5 hours, 7 students who get 6 hours, so on and so forth, until you get to 3 students who get a full 10 hours. Now this is the frequency, or we call this letter F. Now relative frequency is when you take your frequency and divide it by your n. And I've done a little bit of work here adding these numbers up, because if we want to talk about the cumulative frequency here, there are 2 students here. If I add 2 plus 5, that gives me 7. 2 plus 5 plus 7 gives me 14. And again, this slash down here is going to be the sum of f. And then 2 plus 7 plus 14 plus 12 gives me 26. 26 and 14 give me 40. And then we have 47. And then we have 50. So we have 50 students in this total survey. So if I go 2 divided by 50, I get an answer of 0.04, or 4% of those in the survey get 4 hours of sleep on a school night. Now 5 out of 50, that gives me 0.1. Now again, with a little math grammar, I'm going to stylistically put a 0 there, so that looks like 10% gets 5 hours of sleep. And then 7 divided by 50, this gives me 0.14, or 14%. 12 out of 50, and that 12 out of 50 gives me 0.24, or 24%. And 14 out of 50, this is our biggest group here, so 28% get 8 hours of sleep, which is good. And then 7 divided by 50 is going to be 14 again, just like we did at 6 hours of sleep. And then finally 3 out of 50 gives me 0.06. Now if we look at cumulative frequency, which is the sum of f divided by n, we're going to take that 2 divided by 50 and get 0.04. Now, I could keep taking this total, the 7 divided by 50, or I could just kind of accumulate the relative frequency. So this is 14%. Basically 14 plus 14 gives me 28, and then 52. And let's put things in context now. This is stating that 52% of our survey got 7 hours of sleep or less. So the cumulative frequency is always from smallest to biggest, and here we have 80%, 94%, and again, how I get this is I add up the 4, the 10, the 14, the 24, the 28, and the 14, and that makes 94, and the 94 and the 6 makes 1, but I'll put 2 stylistic zeros there so you can see this is 100% of the data. So what we're going to do is we are going to, first of all, take a quasi-mathematical step and find the 90th percentile by just technique number 1. Let's just look at the chart. If we just look at the chart for the 90th percentile, we can see that we would be between the 80 and 94 right here. And if I follow this over, this puts me here at 9. Now the reason why I know I'm at 9 is because I would have several 9s. There was actually 7 of them, and that means that my 90th percentile is going to be at 9. So therefore this gives me my 90th percentile is getting 9 hours of sleep. Now here's another cool way to look at this. If I'm trying to find my 90th percentile, you can see that my 90th percentile is between the 80th and the 94th percentile here. So that's how I'm getting to my answer of 9 instead of 8. Because all the 8s basically, because I think that's what a common question students have for me. It's like, how'd you know it was 9 versus 8? Well, all the 8s basically end at the 80th percentile, and then the 9s start at the right after that and go on to the 94th percentile. So since we're in this zone, we're going to say that the 90th percentile is here at 9. Another way to look at this with a little bit more mathematics is you can take your sample size, n, and multiply that by the percentile, which is 0.90 in this case. So 50 times 0.90 is the 45th person from the bottom. Now, how I know that would be somebody getting 9 hours of sleep is if I'm at the 50th person and count back 3, that would put me at the 47th person. Then the 46th and 45th would be at 9 hours of sleep. So this answer can be achieved in many different ways. One way is looking at the chart, the other way is doing this quick, simple little formula. So if we do the 80th percentile, this is kind of a special tweak because this is landing on one of our numbers. So you'll notice that 80th percent, this is landing right on it. It wasn't between it. Well, what your gut is telling you is that it's exactly 8, because the percentile definition is the number that's below this. But a little tweak that we have to do if we're looking for a specific a percentile that happens to be on our chart is we have to take the average of the next one up from there, because the 8s actually stop at 80 percentile, so we actually can't use the 8. So the answer is actually the average of 8 plus 9. So we take our 8 plus 9 divided by 2, and that gives me 8.5. So my answer for the first technique of just look at the chart, we see that we're landing on the percentile, so we have to take that number and average the next number up. Another way to look at this, step number 2, is again take our n and multiply by our 0.80, and that gives me, in this case, 50 times the 0.80, and this gives me my 40th person, and my 40th person would be exactly 8 or 9. It'd be kind of like between the two, because you can see that the 40th person would be right there at the 9. So there's a little bit of debate to be had about this technique that I'm showing you with the n times the 80. In fact, you're going to see a formula on the next page where they add a half to it, and you'll never run into this kind of looking at the chart complication again. So if you found this method of looking at the chart a little fuzzy, that's okay. You're going to be able to use a different formula to kind of get you through the problem. But for problems where we're looking at percentiles that aren't specifically right on a cumulative frequency, you're going to find that it's pretty straightforward just to look at the chart. So we're now looking at the 5-number summary. In the 5-number summary here, we know that the minimum is 4, and this is all looking at the chart here, and the maximum is 10. Now the median. So let's go take a look again. If we scroll upwards here, if we look again, the median is 50%, and we can see that since we're not exactly on the 50%, what's good about that is that we can see that that would be a 7. So the median is a 7. The 25th, or the Q1, is going to be again a 6 because we're exactly not on one of those percentiles. And then the Q3 at 75% is going to be an 8. So it's really great to look at this chart when we're not landing specifically on one of the percentiles. But, you know, again, in those situations we have a formula. So the median, which is the 50 percentile, is going to be a 7. The Q1 is going to be a 6, and the Q3 is going to be an 8. So here's our minimum, here's our maximum, here's our median, here's our Q3, and here's our Q1. and we're going to make our rectangle, and we're going to make our whiskers in the box plot. And you can see that it's a perfectly symmetrical box and whisker plot. Now the big question is, are there outliers? And this is great because this lets us review from the previous video our little outlier technique. Now remember, step 0 is to put your numbers in order, but what's great about this is you don't actually need all the numbers since we actually have all the work done ourselves. So step 0, put the numbers in order, which we don't need to really do in this case. Step 2 is to find the median, which we have, and our median was useful in finding the Q1 and the Q3, but since we have the cumulative frequency percentiles, we can find the Q1 and Q3 by just saying the Q3 was 8 and the Q1 was 6. Now our IQR, to remind ourselves here, was Q3 minus Q1, so that is going to be 8 minus 6, which is giving you 2. Then we take our 1.5 and multiply it by our IQR, and this gives us 1.5 times 2, and our answer there is 3. Now, going 3 spaces away from this upper bound, like is there any data point here, 3 spaces away from 8? Or is there any data point here, 3 spaces away from Q1? So if we're showing the math on that, we would have our Q1 minus 3, and Q1 minus 3 is going to be 3, because that would be 6 minus 3 is equal to 3. And then we're going to have our Q3 plus 3, so 8 plus 3 is equal to 11. So were there any data points less than 3? Nope, nobody got less than 3 hours of sleep. Were there any data points higher than 11? Nope, nobody got 11 hours of sleep. So since no numbers below 3 or no numbers greater than, that's a greater than, no numbers greater than 11, we have no outliers. Alright, so this whole page here was done basically looking at the chart. To review before we go on to the next page, everything worked really well unless we landed on a number. So if we were looking at the 50th percentile, we looked at the number right above the 50 and saw that the 50th percentile was a 7. If we were looking at the 25th percentile, we'd see it's between here and here, and so this would be the 25th percentile. And the 75th percentile, this number would be in the 75th percentile because it would be here and here. So it's really easy unless we're landing on a number, and then we have to do the average of the two. But is there a formula? Is there a way that we can just kind of turn our brain off for just a little bit and figure out, like, oh, I can do this problem without trying to worry about these exceptions and rules? And there is. There's the kth percentile formula right here, which gives you this formula, which is great because you can actually have this in front of you and use this, because you have the k equals the kth percentile, and then the I is the index and the target number from smallest to largest, and this is why you always order your data, and then n is the number of data. So here's a list of ages who went to a retirement dinner. What we're trying to find is we're going to try to find the 70th and the 83rd percentile. Like which people would these be here? Like how old would the 70th percentile be? How old would the 83rd percentile be? So I'm going to first of all just kind of stratify this. I'm going to have this for the find the 70th percentile. Oops, click my pen here. Find 70th percentile. Okay, so what age represents the 70th percentile? So we first of all have to start off with k. Our k is going to be our kth percentile, so there's 70 right there. Then we're going to figure out our sample size, and in this case, I've done the adding for you. There are 29 people in this list. So according to the formula that just fell off the page, let me just kind of sneak that back up here again. Alright, there it is. So to basically use this problem, I am now going to plug the numbers into the equation. So to find my index I, which is going to be my target number, counting from the bottom, I'm going to take my k, which is 70, and divide it by 100, and then take my sample size 29 and add 1 to it. So this gives me I equals 70 over 100 times 30. Now, using your graphing calculator, you can go 70 divided by 100, which is the same thing as 7/10 or 0.7. And 0.7 times 30 gives you an answer of 21. Now, 21 is not the age. 21 is the index, which means you would count from the bottom, the target number from smallest to largest. And when you get to the 21st number, that number will be the age at the 70th percentile. So let's do some counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to put a little 10 above the 33 just so I know where I am. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm at the 20th now, and the 21st person, or my index at 21, is the 64-year-old. So the 70th percentile is 64 years old. Now we're going to get to the 83rd percentile. Now, what made the last problem a little easy is that the index was a whole number. What's going to make this a little weirder is that the 83rd percentile is not going to give us a whole number. So k is equal to 83, n is equal to 29, and so our equation is, again, from up above, I is equal to 83, divided by 100 times 30. Okay, we process this out, and this is going to give us, on our calculator, 24.9. Okay, so we are not on a specific number, and in that case, what we have to do is we have to basically find the 24th person, and then we find the 25th person. Sorry, got a little smudge there I want to erase. There we go, get rid of that. So we find the 24th and the 25th person and average it. So even though this 24.9 is really close to the 25, what we have to do is find the average of whatever it's between. So if this is a 24.1, we would still take the 24th and 25th person and find the average. So the 24th person, if this is 22, 23, 24, and then 25. So we're going to take our average, we're going to take the 71 and the 72, find our little average of the two, and in doing so, this gives me 71.5. So the 83rd percentile is 71.5 years old. So this technique is great if it lands directly on the number. You can just tell me what that number is. And if it lands between two numbers, just find the average of the two. Okay, so to wrap the video up, we have one more formula, which is great because you can keep it in front of you. It's finding the percentile of a value. Whoops, went a little too far. Sorry about that. So in this case, we're going to find the percentile for a person who is 25 years old, and then find the percentile for someone who is 58 years old. Now, this equation is just a little bit different here. X is the number of data values counting from the bottom, not including that target. Then your Y is going to be the number of data values equal to the data value you were targeting. Then we have N being the number of data points. So what we're going to have is to find the percentile and let's do the 25-year-old. 25-year-old. So the age of 25 is actually the index in this problem. It's kind of our target. Now it says, let's count the number of data pieces below that, not including the target. So if I go back to the data set, which I could scroll up if you'd like me to, but I'll just have you look up at the top of your worksheet here, how many data points are below your index? And the answer is 3. So x is equal to 3. Then y is how many data values are equal to the 25. Well, in this case, we don't have any duplicates, so y is equal to 1, because there was only one of your index numbers that matched an age, which was 25. I really like this technique because if you have multiple ages that are the same, or multiple numbers that are the same, or looking for a target that isn't actually on your field, this formula compensates for it. Now n is the sample size, and we know that n is equal to 29. So our formula now is 3 plus 0.5 times 1 divided by 29. Then you multiply that by 100. So you take your 3 and add your 0.5 times 1, so 3.5 divided by 29. Make sure you do 3.5 and divide that by 29, and then multiply by 100, and do your order of operations, or else you won't get the right answer. And you get 12.07. And the 12.07 you would then round to the nearest percentile. So therefore your 25-year-old is going to be in the 12th percentile. All right, not bad, not bad. So let's do our last problem here. Our last problem is finding the percentile of the 58-year-old. Okay, so the 58-year-old, your x, we're going to have to count how many people are below the 58. Now I would count very carefully, because the 62nd person, or the 62-year-old was the 20th person, therefore the 58-year-old is the 19th person, so there are 18 people below the 58-year-old. There is one 58-year-old, so we are only going to have the y is equal to 1, and our n is equal to 29. So here's our formula. We're going to have 18 plus 0.5 times 1, which is 18.5 if you do this out, divided by 29, do that second, and then multiply by 100. If you do that, you get an answer of 63.8, and we would round this to the nearest percentile. So the 58-year-old is 64th percentile. And there you go. That is how you will find percentiles from a given set, or you can find the ages from a given percentile. Keep these formulas handy because they'll be really good for doing the homework problems. Have these in front of you, get some practice, and be sure to write down some work because doing them in your head is probably not the best idea. All right, thank you for watching.